This is a video from section 9.5 of first order linear differential equation can be written in the form y prime plus p of xy equals q of x. So what I have written is an example of a first order linear differential equation. So we have y prime plus x squared y is equal to sine x. So in this example, p of x is equal to x squared, and q of x is equal to sine of x. To solve the linear differential equation y prime plus p of xy equals q of x, multiply both sides by I of x, which is equal to e to the integral of p of x dx, and then integrate both sides. I of x is called an integrating factor. Now, when solving these types of differential equations, we need the product rule. And so let's recall the product rule. The derivative of f of x times g of x is equal to f prime of x times g of x. So in other words, we're going to take the derivative of the first function times the second function. And we're going to add f of x times the derivative of g of x. So we're going to add it to the first function times the derivative of the second function. And with that in mind, let's do some examples. So here the directions say solve the differential equation. Let's take a look at example 1. Suppose I had y prime minus y equals e to the x. In this example, p of x is equal to -1. And so that's going to allow me to get my integrating factor, which we call I of x. This is going to be e to the integral of -1 dx. But this is equal to e to the negative x. So what I'm going to do is I'm going to multiply both sides by that integrating factor. So we're going to take e to the negative x times y prime minus y, and this is equal to e to the negative x times e to the x. Now, e to the negative x times e to the x is just 1. And then on the other side, we get e to the negative x y prime minus e to the negative x times y. But I want you to notice something. Notice how the derivative of y is y prime. The derivative of e to the negative x is negative e to the negative x. That's by design. So the way I'm going to write this is I'm going to write this as the derivative of e to the negative x times y. It's product rule. That's on the left side. On the right side, we get 1. So e to the negative x times y is equal to the integral of 1 dx. So e to the negative x times y is equal to, now what's the function whose derivative is 1? That's what we're doing. Well, that's x plus c, right? If I solve for y, I got to divide both sides by e to the negative x, right? And so we get y equals x over e to the negative x plus c over e to the negative x. And so therefore, y is x e to the x plus c e to the x. And that's example 1. Let's take a look at example 2. Suppose I had 2xy prime plus y equals 2 root x. So I have to write that first order linear differential equation in this format. So y prime plus p of xy is equal to q of x. And as you can see, it's not written in that form because what's being multiplied by y prime is 2x, right? And so what I need to do is I need to divide everything by 2x, like this. And so y prime, if you don't mind, I'm going to write this, I'm going to write it in this way. So I get y prime plus 1 over 2xy is equal to, the 2's cancel, and we get 1 over square root of x. So in this situation, p of x is 1 over 2x. So that's going to get me my integrating factor. We get I of x is e to the integral of 1 over 2x dx, which is e to the integral. I'm going to pull the 1/2 out, and I'm going to integrate 1 over x dx. But this is e to the 1/2 natural log of x. But remember that e to the 1/2 natural log of x is e to the natural log of x to the half. But this is x to the half. Okay, and I'm going to multiply both sides right here by x to the 1/2. So I get x to the 1/2 times y prime plus 1 over 2xy. That's on the left side. On the right side, I'm going to take x to the 1/2, and I'm going to multiply by 1 over root x. So x to the 1/2 y prime plus, I claim this is 1 over 2x to the 1/2, right, times y is equal to 1. And remember that x to the 1/2 is equal to square root of x. So if I take square root of x times 1 over square root of x, that's just 1. So once again, this is by design. Notice that the derivative of y is y prime. The derivative of x to the 1/2 is 1 over 2x to the 1/2, I claim. So I'm going to take the derivative of x to the 1/2 times y. So it's the product rule again. That's on the left side. On the right side, we get 1. So x to the 1/2 times y is the integral of 1 dx. So x to the 1/2 times y is equal to x plus c. And if I divide both sides by x to the 1/2, I'm done. So I get y equals x plus c over x to the 1/2. And if we want to split off the fraction, that's fine. So you could write this as y equals, and I could write this as x to the 1/2 plus cx to the negative 1/2. So remember, x to the first over x to the 1/2 is x to the 1 minus 1/2, right? And this is x to the 1/2. That's where I'm getting that first term from. And that's how you do example 2. Example 3. Suppose I had the following. xy prime minus 2y equals x squared. In this example, they impose a condition that x is positive, which we want that, and you'll see why in a second. So I need to divide both sides by x. So I get y prime minus 2 over xy is equal to x squared divided by x. Now, in this example, p of x is negative 2 over x. And so my integrating factor is e to the integral of negative 2 over x dx, which is e to the negative 2 natural log of x, which is e to the natural log of x to the negative 2. And so, therefore, I of x is e to the natural log of x to the negative 2, but e to the natural log of x is just x. And so this is x to the negative 2, right? And even better, I'm going to write this as 1 over x squared. So I'm going to multiply both sides by 1 over x squared. So we get 1 over x squared times y prime minus 2 over xy. Now, that's on the left side. On the right side, now, by the way, this is just x, right? So this is going to be x times 1 over x squared. So 1 over x squared y prime minus 2 over x cubed y. That's the left side. On the right side, we get 1 over x. Now, again, this is design, right? So notice how the derivative of y is y prime. I claim the derivative of 1 over x squared will be negative 2 over x cubed. So on the left side, I'm going to write this as the derivative of 1 over x squared times y. They follow the same pattern. On the right side, I get 1 over x. So 1 over x squared times y is the integral of 1 over x dx. So 1 over x squared times y is natural log of x plus c. Remember, natural log of x is the function whose derivative is 1 over x. That's what I want, right? So y is x squared natural log of x plus cx squared. And that's how you do example 3. Let's take a look at example 4. Suppose I had y prime minus 3x squared y equals x squared. In this example, p of x is equal to negative 3x squared. And so to get my integrating factor, I get e to the integral of negative 3x squared dx. Well, that's just e to the negative x cubed. And so I'm going to multiply both sides by e to the negative x cubed. That's my integrating factor. And notice I'm doing that every single time. So I multiply the left side by e to the negative x cubed. I'm going to multiply the right side by e to the negative x cubed. Okay? And so e to the negative x cubed y prime minus 3x squared e to the negative x cubed y is equal to x squared e to the negative x cubed. So notice how the derivative of y is y prime. The derivative of e to the negative x cubed is negative 3x squared e to the negative x cubed. That's just chain rule. So I'm going to write this as the derivative of e to the negative x cubed times y. That's the left side. On the right side, we get x squared e to the negative x cubed. So e to the negative x cubed times y is the integral of x squared e to the negative x cubed dx. Now, from here, if we need to, we could do a u substitution. That's fine. So I'm going to let u be negative x cubed. So du is negative 3x squared dx. Now, so x squared dx is negative 1/3 du, right? So therefore, e to the negative x cubed times y is negative 1/3 times the integral of e to the u du. And so e to the negative x cubed y is negative 1/3 e to the u plus c. But u, remember u is negative x cubed. And so e to the negative x cubed times y is negative 1/3 e to the negative x cubed plus c. Divide both sides by e to the negative x cubed. So y is negative 1/3 plus ce to the x cubed. And that right there is example 4. Let's take a look at one more example for this video. We'll take a look at example 5. Suppose I had 4x cubed times y plus x to the 4th y prime is equal to sine cubed x. This problem is interesting because I want you to notice something. Notice how the derivative of y is y prime. The derivative of x to the 4th is equal to 4x cubed. So we're able to write it in this way right away. You could write this as the derivative of x to the 4th times y. And on the other side, we get sine cubed x. Now, one thing I want you to keep in mind, if we do it like the other problems and divide both sides by x to the 4th and get my integrating factor and multiply both sides by that integrating factor, you're going to wind up right here to begin with. So something to keep in mind. If you see it, it's ideal to go from here to here. Okay? Now, from here, we're going to say x to the 4th times y is the integral of sine cubed x dx. Now, the way you integrate a sine cubed is I'm going to rewrite it this way. I'm going to take x to the 4th times y, and this is the integral of sine of x times sine squared x dx. So x to the 4th times y is the integral of sine of x times, remember that sine squared x is 1 minus cosine squared x. And then we're going to integrate with respect to x. Now, we could do this by u substitution. Let u be cosine of x. Du is negative sine x dx. So sine x dx is negative 1 du. And so x to the fourth times y is negative the integral of 1 minus u is cosine x. Okay. And so we're integrating 1 minus u squared du with a negative on the outside. So x to the fourth times y is the integral of u squared minus 1 du. So x to the fourth times y is 1/3 u cubed minus u plus c. But u is cosine x. And so x to the fourth times y is 1/3 cosine cubed x minus cosine x plus c. And I'm going to divide both sides by x to the fourth, and I'll be done. So we get 1 over 3x to the fourth cosine cubed x minus 1 over x to the fourth cosine x plus c over x to the fourth. And that will conclude this video for section 9.5. We worked 5 examples of solving first-order linear differential equations. Okay, thank you.